Today we're going to learn about conditional probability. Informally, conditional probability asks for the probability that one event theta 2 happens given that another event theta 1 has occurred successfully. Does knowing whether or not an event theta 1 occurred change the likelihood of theta 2? If so, the likelihood of event theta 2 depends, i.e. happens conditionally, on event theta 1. Conditional probability is so important because in reality, random events are affected by other events. Our formal definition is for two events theta 1 and theta 2 within a probability space, the conditional probability of theta 2 given theta 1, denoted as probability of theta 2 given theta 1, the given symbol is this up and down line, is calculated as follows. Probability of theta 2 given theta 1 is equal to the probability of theta 1 intersection theta 2 divided by the probability of theta 1. I always remember that even though this is a straight up and down line, the probability of theta 1, the second piece, the given piece, will always be the denominator. Interpretation. This conditional probability determines the likelihood of event theta 2 with knowledge that event theta 1 has occurred prior. Note that both events theta 1 and theta 2 occur by the end of the experiment. When conditioning, the sample space changes. Example, the possible outcomes of theta 2 is limited to the scope of theta 1. Alternatively, if theta 1 is the condition that is realized, then theta 2 must occur within the outcome space of theta 1. Note that all other outcomes that do not satisfy the condition, meaning theta complement, are not considered, thereby condensing the sample space in which theta 2 occurs. Interchanging theta 1 and theta 2 do not yield the same probability. If we assume that probability of theta 1 is greater than the probability of theta 2, then the probability of theta 1 given theta 2 will also be greater than the probability of theta 2 given theta 1. Number 1, given is a table of the passenger class and survival status of various Titanic passengers. Part A, what is the probability that a randomly selected Titanic passenger is either alive or crew? This is asking for the probability of a live union crew. Use the addition rule to solve. The probability they were alive is 711 out of the total. The probability they were on the crew is 885 out of the total. And the probability of the intersection alive and crew is 212. As a decimal, this becomes 0.6288, which would truncate to be 0.628 or round to be 0.629. Part B is asking, what is the probability that a randomly selected Titanic passenger is alive given that they were third class? This one is asking for a conditional probability, the probability they are alive given third class. Using the formula for conditional probability, that would be the probability of a live intersection third class divided by the probability they were in third class. The intersection of alive and third class is 178 out of the total. The probability of third class is 706 out of the total. Divide and you get 178 divided by 706. As a decimal, 0.252. What is the probability that a randomly selected Titanic passenger is second class given that they were dead? This is another conditional probability, second class given dead, is equal to the probability of the second class intersection dead over probability of dead. The intersection is 167, and the probability that someone is dead is 1490. Divide, and you get 0.112. What is the probability that a randomly selected Titanic passenger was first class or crew, given that they were alive? This is asking for conditional probability with union, the probability of first class union crew given alive. Notice how first class and crew, there's no overlap, so there's no need to subtract an intersection when we're calculating the union. This is equal to probability of first class given alive plus probability of crew given alive. The probability of first class intersection alive is 203 out of the total. The probability of crew intersection alive is 212 out of the total. And the probability of alive is 711 out of the total. Simplify. As a decimal, you get 0.584. The formulas for this maybe looked a little confusing, and you may have actually been able to figure this out intuitively by saying, oh, first given alive plus crew given alive, 203 over 711 plus 212 over 711. You can absolutely skip the step with all the totals if you feel more comfortable calculating these probabilities intuitively. What is the probability that a randomly selected Titanic passenger was dead given that they were second class or crew? The probability of dead given second class or crew, well, second class and crew are disjoint. There's no intersection, no overlap. So our fraction will be probability of dead intersection second or crew over the probability of second or crew. The probability of dead and second class would be 167 over the total. The probability of dead and crew is 673 over the total. But our denominator would be the union, so 285 total second class passengers and 885 crew members. Add your numerator and your denominator fractions, divide, and your decimal is 0.718. What is the probability that a randomly selected Titanic passenger was alive given that they were not crew? This is asking for the probability they were alive given crew complement. Using the formula for conditional probability, that would be the probability of the intersection alive and crew complement over the probability of crew complement. The intersection of alive but not in the crew would be 203 plus 118 plus 178 over the total. The probability for crew complement uses the totals, 325 in first class, 285 in second, and 706 in third class, divided by the total. And that would be 0.379. And that is conditional probability.